Welcome to Lesson 2 of Module 3, covering developing conversational applications. Foundation models and large language models are at the core of generative AI. These powerful models serve as the foundation for numerous advanced applications, enabling us to tackle challenging tasks more effectively. Foundation models and large language models are versatile and can be adapted to various domains. This presentation delves into the concepts and capabilities of these models, which are driving innovation in the field of generative AI. Today we'll be covering three main activities that will build upon what we learned previously. First, we'll begin with a review of Lesson 1 on LangChain. Next, we'll explore the evolution from simple question and answer interactions to more sophisticated conversations. Finally, we'll delve into customizing chat applications. Let's review LangChain. It has emerged as one of the most influential frameworks in the LLM space. This framework is specifically designed to make building LM-powered applications more straightforward and efficient. What makes LangChain particularly valuable is its modular approach. You can mix and match components as needed for your specific use case. Its flexibility means it can handle everything from small prototype projects to large-scale applications. One of LangChain's greatest strengths is its extensive third-party integration support, which means you can easily connect it with other tools and services you're already using. Whether you're building a chatbot, an analysis tool, or a complex AI application, LangChain provides the building blocks you need to make it happen efficiently and effectively. A simple LLM chain looks as follows. First, we define a prompt template using the prompt template class with a simple structure. This template creates a standardized way to format our inputs before they reach the language model. Next, we create the chain by connecting these components with the pipe operator. The flow goes from prompt template to LLM to string output parser, creating a processing pipeline that handles the entire workflow from input formatting to output processing. The example demonstrates invoking this chain with specific parameters, requesting a bedtime story about a cat. The green text shows the beginning of the generated response, which appropriately starts with "once upon a time" and introduces a character named Midnight. This pattern illustrates how LangChain enables clean, modular design when working with language models, allowing professionals to create reusable components that can be assembled into more complex applications. In this slide, we'll review how AI systems utilize memory in conversations. The example shown demonstrates a simple but powerful concept: the ability of AI to remember and reference previously shared information. An LLM can therefore remember a user's name. Now, we'll transition from simple question and answering to conversations. In this discussion, we'll explore chat models and their capabilities. These specialized LLMs are designed to handle natural conversations effectively. What makes them particularly powerful is their ability to process both system messages and maintain context through conversation history. Through LangChain, we can integrate these models with various messaging platforms you likely use daily, from Gmail to WhatsApp, making them highly versatile for different applications. This integration capability is crucial for businesses looking to implement AI-powered communication solutions across multiple channels. Now, we'll explore Amazon Bedrock's comprehensive suite of chat-optimized models. As you can see, it has several leading AI models integrated into its platform, including Amazon's Nova, Anthropic's Claude, Meta's Llama, Mistral AI's Mistral Instruct, and Cohere's Command Model. Each of these models has been specifically optimized for chat applications and brings unique strengths to the table. I encourage you to refer to the individual model cards for detailed specifications and performance characteristics to help you choose the right model for your specific use case. This diversity of models ensures that you can find the perfect fit for your application's requirements. In this slide, we're looking at how to structure chat prompt templates for AI interactions. The template shown demonstrates a basic conversation flow with three key components: system messages that define the AI's identity, human messages for user inputs, and AI responses. The code example shows how to create a template where Andy is set as the AI's name, and it handles a simple interaction asking for the user's name. Notice how the template uses placeholders and curly braces for dynamic content, making it flexible and reusable. When presenting this, emphasize how this structure helps maintain consistent AI behavior while allowing for dynamic interactions. The system message is particularly important as it sets the foundation for how the AI will behave throughout the conversation. Now we'll explore the fundamental differences between question and answering and conversational AI approaches. While both utilize LLMs, they serve different purposes and have distinct characteristics. Question and answering systems are like asking a question to a fresh slate each time, perfect for standalone queries, but without memory of previous interactions. Think of it as consulting a knowledgeable expert for a specific question. Conversational AI, on the other hand, is more like having an ongoing dialogue with someone who remembers your previous interactions. This makes it ideal for more complex multi-turn interactions where context is crucial. The technical implementation differs too. Question and answering systems are simpler, while conversational AI requires additional memory mechanisms to maintain context. This affects both the architecture and use cases for each approach. Remember, choosing between question and answering and conversational approaches depends on your specific use case. Consider factors like need for context retention, complexity of interaction, and technical requirements. Now, let's discuss the process of building a chatbot. Now we'll discuss the fundamental components that make up a basic chatbot system. While this may seem simple with just 3 main components, each plays a crucial role in creating an effective conversational AI. The LLM is our powerhouse. It's what enables the chatbot to understand and generate human-like responses. The prompt template acts as the chatbot's personality and rulebook, ensuring it stays on track and maintains its intended purpose. Finally, the memory module is what gives our chatbot continuity, allowing it to remember previous parts of the conversation and provide more coherent, contextual responses. As shown in the diagram, these components work together in a synchronized flow, from receiving user input to delivering appropriate responses. This basic architecture can be enhanced with additional features, but these 3 components form the essential foundation of any functional chatbot system. Remember, while the system appears straightforward, the sophistication lies in how these components interact and complement each other to create a natural conversational experience. In this implementation, we're creating a simple but effective chatbot system. The key components include memory management for maintaining conversation context, a processing chain for handling inputs, and methods for retrieving and storing chat history. The conversation buffer memory class is crucial as it allows our chatbot to remember previous interactions, making conversations more coherent and contextual. Notice how we structure the input and output handling to maintain a clear flow of information through the system. This architecture ensures that our chatbot can maintain context while processing new inputs and generating appropriate responses. Now that we've explored the fundamentals of implementing a chatbot with memory capabilities, let's discuss how to customize chat applications to better serve specific use cases. Customization is essential for creating chat experiences that align with your particular needs. Generating responses is resource-intensive, involving substantial costs, compute power, and time. However, by implementing response caching, we can drastically improve efficiency. When users ask similar questions, we can instantly retrieve previously generated responses from our cache, eliminating the need for repeated processing. This not only saves resources, but also significantly reduces inference time, leading to better user experience. Think of it as having a smart memory system that helps us avoid doing the same work twice. First, let's look at in-memory caching. This is your speed champion. It's blazing fast because it stores data right in your application's runtime memory. However, remember that it's like short-term memory. Once your application restarts, that cache is gone. It's perfect for situations where you need lightning-quick access to temporary data. Moving on to persistent caching, think of this as your long-term memory solution. While it might be a bit slower than in-memory caching, it's much more reliable because your data persists even when your application shuts down. This makes it ideal for scenarios where data preservation is crucial and when you're building scalable applications. When choosing between these two, consider your specific needs. Do you prioritize speed over persistence? Or is data durability more important for your use case? The answer to these questions will guide your caching strategy. Caching is most effective for deterministic queries, those with consistent, predictable outputs. When we set the temperature to 0, we ensure reproducible results, though this may limit creative variations in responses. A critical challenge we face is managing cache data freshness. Always implement expiration policies to prevent serving outdated information. I recommend setting appropriate TTL values based on your use case. Lastly, don't overlook storage requirements. Your caching solution needs to scale with your application. Choose a database that can handle your expected cache size and access patterns. Remember, effective caching can significantly improve performance, but it requires careful planning and ongoing management. A critical challenge in LLM implementations is managing long conversations. The key point to emphasize is that while they are powerful, they face three main constraints. First, think of the context window like a computer's RAM. It's limited and needs to be managed efficiently. Each model has a maximum number of tokens it can handle at once. Second, as conversations grow longer, we often see redundant information piling up. Imagine having to repeat your introduction in every email of a long thread. That's what we want to avoid. Finally, there's the cost factor. The longer the conversation gets, the more expensive it becomes to process, because each new interaction requires reviewing all previous content. This creates a compounding effect on computational resources. Now we'll discuss the conversation buffer window memory system, a crucial component for managing dialogue history in conversational AI applications. The key point to emphasize is that this system provides an elegant solution for maintaining conversation context while preventing memory overload. Unlike unlimited buffer systems, it keeps only the most relevant recent interactions. When implementing this in your applications, pay special attention to the K parameter. It determines how many past interactions you want to maintain. Too small a value might lose important context, while too large a value could impact performance. The code example demonstrates a simple implementation with K equals 1, but in real-world applications, you might want to adjust this based on your specific use case. Remember to handle the input-output pairs carefully, as they form the foundation of your conversation history. The system automatically manages the sliding window, but you should still monitor memory usage in production environments. Moving beyond the simple buffer window approach, we now explore the conversation summary memory technique. This method leverages the power of a LLM to create intelligent summaries of conversation history. The key advantage here is how it handles lengthy exchanges. Rather than simply dropping older messages or keeping a fixed number of recent interactions, this approach distills the important information into concise summaries. This is particularly valuable when dealing with extended conversations or messages containing substantial content. Now we'll discuss how context plays a crucial role in understanding and processing information. While many might think context is simply about past conversations or interactions, it's actually much more comprehensive. We have three main types of context to consider. First, there's relevant information that directly pertains to our current discussion. Then, we incorporate external data that helps broaden our understanding. Finally, and perhaps most importantly, we have human feedback, which helps refine and improve our understanding. Remember, the power of context lies in its versatility. It's not just about what was said before, but about creating a complete picture using multiple sources of information. This comprehensive approach helps ensure more accurate and meaningful interactions. This diagram illustrates how user input, document content, and system memory come together in the prompt engineering process. The key challenge we need to consider is the implications of feeding entire documents into the prompt. This can lead to several issues such as token limitations, processing overhead, memory constraints, context window limitations, and potential information overload. Understanding these challenges is crucial for developing effective document-based chat systems and implementing appropriate solutions for document handling and processing. There are several critical limitations of LLMs. These limitations are important to understand as they impact how we can effectively use LLMs in practical applications. First, we must acknowledge that while LLMs are powerful, they aren't perfect. They can be unreliable and may contain biases from their training data. Their knowledge is frozen at the time of training, and they can't independently verify truth from fiction. One of the most concerning issues is hallucination, where models generate convincing but false information. This is compounded by context window limitations, which restrict how much information they can process at once. From a practical standpoint, these models require significant computational resources, typically needing powerful GPUs to run effectively. Finally, we need to be mindful of potential copyright issues, as these models may inadvertently reproduce copyrighted content. Understanding these limitations is crucial for responsible implementation and use of LLM technology in any organization. In this lesson, we've explored how to develop conversational applications using LangChain, which provides a powerful framework for building interactive AI systems. Looking ahead to our next session, we'll be diving into retrieval augmented generation, commonly known as RAG. Thank you for your participation.